Hi everybody. Today we are going to talk about the emulator 8086, which is a program used to emulate assembly programs. Now we start with writing emulator 8086. After installing it, we go for new and start with an empty workspace. Here you will find your help, which is very useful because you will find all the instructions and tutorials and interrupts ready there for you. Let's say I have an instruction and I want to check, let's say, the add instruction. It will tell me exactly what it will do, and instruction, and so on. It will tell you all the instructions that are needed. Here you have a converter which converts from hexadecimal or binary or whatever. So let's say I have a hexadecimal number which is C31. Okay, it's because it's 8 bits. If I put 16 bits here, C31, it will give you the signed and unsigned number. Of course, it's both signed and unsigned are equal. If I put here A, then you will find that because A starts with a 1, the signed number is negative, the unsigned number is positive, and so on. Now, next here you have your calculator, which calculates decimal, hexadecimal, binary, or octal, and this is how you will show your results, whether you want to show the results in hexadecimal, in octal, or in decimal. You can do all of this from here. Here is our emulator, emulate and compile. So first of all, to start a program, we start with origin 100 hexa. Origin 100 hexa means that put this program in the code segment starting at 100 hexa. I will say add AX, comma, I will give you an example with an error. So add AX, comma, A321. Okay, there's no need for semicolons. Then move to AL to BL, sorry, to move to BL 30 hexa. If you want hexa, then you put an H. Then move to CL BL. Okay, then at the end I will say return. So if I emulate this one over here, let's see if we get errors or not. First of all, I got an error over here, wrong parameter, add AX A321. So first of all, it says here probably no zero prefix or no hexa. Since it's a hexadecimal number, you need to add an H at the end. Still, we will get another error because if you start with a number A, B, C, D, E, or F, you should put a 0 at the beginning. You should put a 0 at the beginning, and then you press emulate. This window will open. Now, this window shows you what's happening. Here you have your AX, this is AL, this is AH, this is BX, BL, BH, CX, CL, CH, DX, DL, DH. Code segment. Instruction pointer is pointing at 100 because our program starts where? At 100 hexa. Stack segment, stack pointer, base pointer, source index, destination index, data segment, and extra segment. These are all your segments. Over here you have the instruction add AX 0A32 1 hexa. Now this instruction takes 3 words inside the memory. The add instruction is 05, the 21 is here, the A3 is here. It's the little Indian convention, okay, that we talked about inside the lecture notes. Over here you see your flag register. If you press on this one, you have your flag register. Here is your stack. Here is your debugging, your variables. If you declare a variables, you will have them over here in this window. Okay, if you double click on AX, you will find all the values. Now let's go a step by step. The first instruction will add AX 0A32. Now the contents of AX is 0, so 0 plus the number, you will get the same value. Instruction pointer now is pointing to the next instruction. Okay, the ones in blue are the values that changed. If you double click On AX you will find all the values in different representations. Okay, so then next I moved 30 into BL. Okay, I moved 30 into BL. Next I moved BL into CL. Now let's do another program. I will remove the hexa from here. Okay, and I will remove the A like this. I will keep the number without hexa, and I will start with move 30 to BL, move BL to CL. Okay, I will move here, and then I will say move to AX 1005. Then I'm going to say, and this is a logical function, and BLAL, sorry, BLAL, and then run. Now if I emulate, we start with moving 30 to BL. So 30 is moved as 1E because 30 in decimal is 1E. If I double click here, you see it's 30 in decimal. In the microcontroller, everything is stored in hexadecimal, so immediately it will be changed to hexadecimal. That's why I advise you to always write a hex H beside the hexadecimal number. Then move BL to CL. Move to AX 1005. AX will have 03 ED. 03 ED, if you double click on it, it will give you the value of the number as 16-bit. Over here you can see it's 1005. Okay, so let's push on. This is the AND instruction. AND AL BL, store the result into BL. Okay, this is the result of ANDing the two values. And again, you can check your flag register. If anything is changed, you can see it over here. Your variables, if declared, you can see them over here. This is a small tutorial to show you that if you want to check, some students ask me, doctor, we want to check our programs whether they are right or wrong. You can check them over here. This only works for 16 bits. It does not work on the Intel. Okay, for Intel programming, we need to use the Microsoft Visual C++, which I know it's not available for you, so I'm not going to ask you to simulate any programs in this task. I just want you to know how to program them. If you want to check them, you can check them here. Here the maximum is AX. We don't have any extended AX or extended BX, any extended registers with 32 bits. It's only 16-bit registers. Hope this small tutorial will help you, and hope to see you all soon.